Good evening, sir. Good evening, sir.
Hello, Bhavna. Am I audible? Hello, Bhavna. Is it audible or not? Hello, Bhavna. Is it audible? Hello, Bhavna. Is it audible? Let me know first.
Hello, sir.
Yeah. Hello, Bhavna. Is it audible?
Yes, sir.
Okay, why you have joined so late?
So some network issue.
Okay. Fine. We are just left with 30 minutes to continue with the class. Okay. Everything is clear in the differentiation part till where I discussed.
Yes, sir.
Okay. So I will go with the new differentiation thing. It's basically some further formulas that you have to remember actually. There's too much, so I won't be providing you the definition or something for that. Okay, so the first thing is some formula, differentiation formula you could remember.
Your voice is not clear, sir.
Okay, still it's not clear, still very.
There's some disturbance coming.
Okay, okay, so some important formulas are there. I'll be writing that. If your y is sine x, okay, differentiation of sine x is nothing but cos of x. For if your cos is this minus sine x. Clear? These formulas we have to remember.
Okay, sir.
Next is tan x. The differentiation of tan x is nothing but secant square x. Differentiation of maybe the cot if I can see minus cosecant square. So you just have to remember which is negative, which is positive. I'll give you a hint which one goes negative, which one goes positive. So the fifth one is secant x. So here the answer comes out as secant x tan x cosecant x. Here it comes out as dy by dx equals to minus cosec x and cot x.
Sir, I can't hear you clearly. Like there's some disturbance coming constantly.
Now I don't have any disturbance around. Still it's a disturbance. Like only fan is is ongoing. Everything is. I don't have any disturbance around me right now. Okay.
So it's
So
like
look,
some wind sound coming while you're talking.
some wind sound is coming. Still wind sound is coming. Like I have turned on off my cooler. Okay, look, Bhavana, in this case, if you see carefully, all the C, the differentiation starting with C, like this one has negative, this one has negative, this one also has a negative. So whatever you have like caught and something, whatever the negative part is, the differentiation of that is coming out to be negative. Okay, the rest are going to be positive. Is this clear?
Okay,
It's
sir.
just a way to remember. Okay, not a thing. More, I don't think makes sense to go because you just have to remember this part. So I'll be giving some differentiation of this thing to try to solve this one and let me know the answer. Okay. So the first is question one: sine x dot sine x and tan x. Differentiation of this one. Let me know the answer. This is the first problem. Try to solve this and let me know the answer first.
So is it cos x and secant square x?
Cos x secant square x. Wait, let me see. Okay, how did you solve this one?
So actually, it's like you said differentiation of sin x is cos x and
No, okay, that makes sense. But isn't it a UV formula, right? Because you have two different things to
yeah,
integrate.
I thought of doing that, but again, like in the formula, there's like sin x is equals to cos x and tan x is equals to secant square x. So I've directly put it.
Oh, wait, I'll just solve it. I didn't solve it right now. So the differentiation will come out as, if I take it as it is, so it will become secant square x sin x plus what is it, tan x and cos. This should be the answer. Okay. And what's your answer? Bhavna, what is your answer?
So I'm doing with this formula like
Okay.
u dot v. So it's sin x secant square x plus
Okay.
cos x tan x.
Yeah, it's fine. Okay. Look, now I'll be just explaining one more thing. It may maybe not worth it for you, but okay. Just assume you are given an integration differentiation of this thing x to the power ex. Okay, one more thing. X to differentiation of this thing. Okay, remove this a. We are doing differentiation of a to the power x. Can you think of it? What you should do here? A is a constant, and x by differentiation we are going to do with respect to dx. So you have to calculate dy by dx. Okay.
Okay, sir. So is it the basic formula which we have learned first?
No, that's the thing, right? Here you can't use it. Look, what is the basic formula? The basic formula says that you have x to the power some constant. So then you can apply
Yeah,
n minus 1
yeah.
and this thing, okay? And then further you can do.
Oh,
But here it is not possible. So how you have to do this? Before this, I'll just give you another formula. That is differentiation of something in log. Okay, if something is there, you know. Okay, what we can do here is I will try to put this equals to log. Okay, what I will do here
okay,
is
sir.
um, I will make log both sides. So it will become log of pi is equals to log of a to the power x, is it?
Yes, sir.
And this thing log of something, let's say x to the power n can be written as n log x, right? This is just a property of log. So from there you can see I can write this thing as x log of a, is it?
Yes.
Okay, now what I have is I have this part log of y is equals to x times of log of a. So now I think I can do the differentiation. Okay, so let's differentiate the whole thing with respect to x. So here you will be having d log of y.
So x log of x.
No, I'm doing it with respect to x itself, right?
No,
Okay, this.
like, yeah.
Okay, I just write that down. So here you have is you now you can see you have u dot v formula, is it? This part.
Yes.
Another way you can say this a was a constant, so it means logarithmic of a will also be a constant. So you don't even have to do differentiate this part, right? You can simply write this as log of a because this is a constant thing. Differentiation of x will go as dx by dx will come out as only log a.
Yes.
Is this clear? Now the part is how you will differentiate this log of y. Okay, so before this, I'll give you the formula. Differentiation of log of anything is nothing but 1 by that thing and dy by dx. Is that clear?
Okay, sir.
Or I can just remove this. I will simply say that differentiation of log x is nothing but 1 by x. Whatever there is inside log, just take it in reverse and you know the next part of the chain rule. You have to go inside if something is there, differentiate it again and again. So here if you see dx is equals to 1 by x. Here, if you see, I have y. So, what is the formula for log? It is nothing but 1 by y.
1 by y.
As per the chain rule, I have done the outer part. I will go for the inner. What is the inner? That is y. So, I will differentiate dy by dx. So, what I have got the answer is this whole thing is equals to a. So, what is my dy by dx? So, you can see my dy by dx is coming out as y times of log of. And what is my value of y? Where is it? This thing, right? So, I can simply put it as like this. A to the power x log of. Is this clear?
Yes, sir.
Understood? And all these log are with respect to E as a base. All these headers E as a base. So you now you have got that if y is equals to a to the power x, basically this is your base, okay? So what is your answer going to be? Your answer of dy by dx is going to be a to the power x log of E as a base and a. This is your answer. Understood? So if I ask you what is the formula for I made it too long, I'll go to the next page. Bhavna, I have shifted to the next page. Can you see this?
No, sir.
Y is equals to e to the power x I have written. Check this one if you can see this.
No, sir.
I have shared it. Wait. Just try to check some by doing some scroll up and down or something.
Yeah, I'm doing. So, no. The last one is like dy by dx is equals to a power x log c.
No, no, it's log e. Okay, e and e as a base and that a. Okay.
Okay.
Wait, why I can't see this? I've shifted to the new page. Check it once, maybe laser on this
Okay.
presentation. Still, you can't see that. I
Yeah,
have written
I can see it now, sir. Y is
now.
equals to EX.
Yeah. Okay. So
E power X.
can you get me the differentiation of this? Okay, I'll just go with this right. Okay. You know, I have just told you the formula. Assume this E is a base, and at the end of the day, we will put the value. Here, my constant is E. So, was the formula? It was A to the power x log of E to the power. Can I put the value of A? Let's put E of x log of E to A. You know what is this value?
1.
Exactly. So the total comes out as one. So what you have noticed is differentiation of e to the power x will also comes out to be e to the power x. Okay.
Okay, sir.
And the best part is now, although we have not studied the integration, but ex is something whose differentiation and integration is the same, comes out as same thing. Okay. That's the thing.
Okay, sir.
All right. So I can give you some more problem based on this. Okay. Can you try to solve another problem? Maybe in 2 seconds. If y is equals to e to the power sin x, can you solve this one?
So is it E to the power cos x?
No, no. It is never going to be differentiated in the power.
Okay. Then sin x as it is?
Yeah, it will be says. Look, what it will go is, it should the it instead of this, if it would have e to the power x, what will be the differentiation? You will say ex, right? It
So
means
is it
we
like E same? It comes out same?
Yeah, it comes out same. Look, what I'm trying to say.
Yeah.
It This part comes out same, but we do the chain rule, right? It means we differentiate every second thing present in the equation. It means I'm left to
Yeah.
differentiate it. But here, what was the problem is this was the thing. So answer was the same, but here what happens? I have sin x instead of this x. So this will come out as if I do the differentiation of this e to the sin x because the differentiation of constant with respect to like e with respect to something variable will come out as the same thing. Okay, it is not just about this part.
So it is a formula, right?
After this differentiate this sin x because we had done the everything. I'm left to differentiate this sin x, right? So if you differentiate this thing, what you are going to get? Cos x at the base. Is that clear? Another way, if you still can't do it, just make the log both side. The moment you make log both side, you'll be having y sin x outside. Okay, I really made a mistake. No, I don't think. So you'll be having sine, what is it, log e of t. Okay, differentiate both sides. The moment you differentiate it, you will be getting 1 by y.
So but
And
you have given a formula just now that
yeah, I have given a formula. I'm just explaining how you can do it with the formula. If you don't, you can use this method also. So yeah, this comes out nothing. If you
so
differentiate this
just
side,
E power sin x is wrong. Again, like dot cos x is the correct answer.
where I have it in the, wait, which part?
E power sin x
No,
dot
there's no
cos x.
dot of differentiation of sine x by dx. It is there now. Then it becomes this the whole thing.
Yeah.
I have
So
just
we have
made.
to differentiate the sign too, like the power
Yeah, you
too.
have to. Like you can see here, right? The earlier part, I had x here. Okay, if I just go back to my
Yeah.
differentiation derivation, When I was doing
Okay,
that thing,
dx by dx is 1.
okay, so here the dx by dx is 1, so I don't have to do that.
Okay,
But here
okay,
the
okay,
sign part is not, the exponential part is not a thing, okay? So in a better
okay.
sense, I will convert this formula into something else. So you can simply say y is the whole thing, e to the power sine x dy by dx. So instead, I should write this formula as, if you have given y e to the power function, okay? So what is the differentiation of this thing? E to the power fx as it is
Sir,
multiplied
again
by,
that wind sound coming.
okay. So you have got something like d of fx divided by x. Clear? Understood this thing? Now I have just rephrased the formula in this part. Hello, Bhavna. Is it? Am I audible?
Hello, sir.
Yeah. Hello. Have you understood this part? This part of the formula?
Uh,
Look,
okay,
I
sir.
have like whatever we have discussed e to the power x. I felt it is incomplete. The reason is if you change this x is something you may get confused. So I just turned it up into the some random function. So you can use this formula. So I will just change
Okay,
the
sir.
a to the power x also. So dy by dx will come out as a to the power x as it is. Log of a was also there and multiplication. Okay, wait a second. It should be fx. Okay, function of x, function of x. So this comes out with log of x and the differentiation of function of x divided by x. Um, just take a minute. Let me know which point you are not clarified with. So this is the formula. Okay. What
Okay,
other
sir.
maybe I can say. Understood everything? I'm giving you one differentiation to do. Just solve and get me the answer.
Okay, sir.
Okay. So it is like e to the power sine of, multiplied by log of e to the power, something I can make. Okay, let's not make it. Log e of e to the power cos cosec x. Can I add something else? Oh, it's more than 1 plus. So this is the thing. This is y equals to 1 plus this whole expression. Get me the differentiation of, get me the value of dy by dx.
Sir, can we apply u dot v formula?
Yeah, exactly. We have to apply. Like if you see carefully, we have two different sections over here. Like one is this, one is this. So these two sections comes under the plus operator. So you can simply say, okay, I will do it as separate. I will do it as separate. If you come up this section, you have two again part, that is u. You have v. So for this two sections, you may have to apply u and v. In further, if you get something like this and this, so you may again have to apply the same thing. Okay. So that's it for now. Let's try to do this one. It's contain multiple concepts at the same time on the basis of a new differentiation which we have studied today.
So I'm not getting the differentiation of the second term.
Okay. So
Log e power e.
okay, which part you are not getting properly?
Log, that log.
Okay, like okay, it's an easy part. What is the problem here is, look, what I told. Be just go in a very basic. If you see what I told is, if you have something like log of y, if you differentiate it with respect to, you'll be getting one by y, and differentiation of this part is it. So do the same. I'll take this part here. I will call
Log
this
of
whole thing
y.
as v. So my law differentiation of dv by dx, what it is? I have a first thing, the most outer thing is log. So whatever the inside the log, just take it in the inverse. So you are going to get e to the power cos x. Is that clear? Now this is in the power.
Sir, please explain the sum.
Okay, wait a second. Okay, should I explain the whole thing or just for the log part?
So explain it. Like
Okay,
the whole thing.
okay. Good. So look, the this is a plus operator in the whole thing. So I can simply say that this is a constant and constant differentiation goes to zero. So I can again write this as
So
zero.
are you
This,
writing?
yeah, I'm writing over here. Can you see
I
this?
cannot see.
Uh, all right, I'll try to switch my page.
I can't see, sir.
You have not followed my. Wait,
Oh,
can you see this now? If I annotate
no,
in a
sir.
random,
Your voice too is breaking.
still you are not able to get this. Like I am
Is it
writing at the.
my net issue or yours, sir?
Wait a minute, I'll try to
No,
do
sir.
it. Okay, this is the last problem. Okay, wait. Bhavna, still you can't see this?
So have you taken the fresh page?
Yeah, I have taken a fresh page and I'm writing some random things over it.
Yeah, yeah, yes.
Okay, now you can
Yes,
get it.
I can see it now.
Okay, so I just forgot the equation which I have wrote there. Just remind me.
Yes.
Because y plus 1 plus maybe e to the power sine of x plus tan of x, right? And I had a log e to the power, like this is not e,
Sine
this
plus tan
this was the
x
base. I had e to the power cosec x, right?
dot log e
This was the thing, I think.
e cosec x.
Cosec. This was the thing. Okay. So if I differentiate this, I have a answer as 0 plus differentiation of the whole thing. Okay, so I will write this as u,
Sir,
this
it's
is
breaking again.
Is it clear till here? Wait, what is breaking? Like voice is breaking or the thing which I am writing it is getting break? Ketan, I think your
I
network issue
can't
is there.
see this notes nor your voice is breaking.
Kirtan, I think there's a voice issue, like there's a network issue from your side, okay? Because my network is going good. What I feel is, yeah, let me check my network back. Yeah, it's good. My network is good from my side. I'm getting good speed. It's uploading or downloading both. Okay, do one thing. Try to solve this problem as a homework because I have to get to the next class also. Hello, Bhavna. So like, I will export the things. So put it like that. Now I will remove it from here from the cross. I will stop ending the session.
Hello, sir.
Hello, hello, Bhavna. Is it audible now?
Yes.
Okay, should I write or okay? Now it's fine if I write something.
Yes, sir, I can see.
Look, I'll directly go with the equation, whatever I had. I had a u as what was my u part? That is e to the power sine of x plus cos. I think that was tan
Yes.
of x, right? My v was how much? Log base is e, so I can remove it because e base is a default. Is cosec x, right? So these two things were there. So what is my y? It was 1 plus u dot v. Is it? I need dy by dx.
Yes, sir.
So what I will left with 0 plus differentiation of u dot v. I will go for this part first. Du dot v comes out as u dash v plus v dash u. Okay, let's do them individual. Du by dx. What is my du by dx? D times of e to the power sine x plus
Plus
tan
tan.
x. Okay. I just told you the formula. What is the formula for e to the power f differentiation?
It comes out as
E to the
EX
power of
dot.
x d times of fx by
Yeah.
dx. Is it?
Yeah.
I'll write the same thing.
Yes.
E to the power sine x plus tan x.
Yeah, the first time I got, sir.
And
Like
differentiation of
this
this
term.
thing you have already done.
Yeah.
What was that? Sec square
It
x
is
sine x
plus
plus
cosec.
sine I already did, so you can keep it as cos x tan. This is what the differentiation of the u part is. The rest is dv by dx. What is it? Differentiation of log cos. It is e to the power cos x, right?
So how can you make it it's sin x plus tan x, right?
Here, which part you're talking about?
Yeah, that part, sir.
This one.
Yeah.
Oh, it will be like this itself, right?
It's u plus v.
Yeah, it's a u plus v. Wait, where is the u? Yeah, like this is the u plus v, right? Okay,
Okay,
wait.
okay.
Okay, sorry. I have done here u dot v, but it should be u plus v.
Yeah.
So wait, that was my mistake. So I can simply, yeah, it's in simple then. I
It's
thought it's,
cos x then
yeah, it will come,
plus
it's a very simple. It will
secant
be cos
square.
x
Yeah.
plus secant square. Now it's fine. Okay, yeah, here let's come up. Whatever the differentiation of log is, it is nothing but 1 by x. Whatever the inside is, just take it up. That's it. Okay. So here what it become, you have this thing inside log, make it in the inverse. As per the chain rule, I'm just left to differentiate this part. Okay, let's come up this thing. D of e to the power cos of, okay, now this thing. And we are very well known how to differentiate this part, is it?
Yes.
So what will be the answer?
E power cosec
I'll just
x.
write the things. If you do this, e to the power cos sec x,
dot
differentiation of, I'll just
differentiation of cosec x.
cancel out. What is this part? Minus cosec x cot x. Clear? Clear the thing?
Okay, sir.
And if I just merge the whole thing, whatever I have it, what I'm going to get is dy by dx 0 plus u dot v, differentiation of u dot v, right? So,
Yes.
okay, it's a very long thing to write, right? So first of all, u
Yeah.
dash. What is the u dash? This part is of the u dash. So I can simply say e to the power sine x plus tan x cos x plus, what is the next part? Maybe secant square x. This is the u dash. Along with it, I had to keep v. And what was the v?
V
Simply log
log e
e to the power cos sec
cosec.
x. Clear? Then
Yes.
differentiation of this thing, only this part, the very small. Okay. So I'll just remove this negative, put it negative. Cosec x cot x. What is the
So why
another part left?
negative?
This is negative, right? Sign convention.
Okay, 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 sir.
The positive was there, but due to its negative, the positive negative becomes
Oh,
negative.
okay, sir. Okay.
And what is the value of u? That was e to the power sine x plus tan x. So this is the differentiation, and if you just put it like this is the whole thing. Okay, I'll just take it from here. So yeah, that's the answer. Clear?
Okay, sir.
Although I don't think you will get these kind of equations to solve in general. Okay, in
Okay,
your
sir.
practice. So yeah, Kirtana, that's what's yeah. Bhavana, that's all for the today's class. Okay, by this I'll end this session.
Okay, sir.
And any queries you have, let me know, or else we will move. We'll take the next class for this. Your express to come. Okay.
Okay, okay, sir.
Okay. So bye. I'm ending the
Okay,
session
sir.
by this.
Okay, sir.